So, quick review of Venn diagrams, and then we'll look at one sample problem from this section. Suppose I've got a universal set of objects, and we'll call that universal set U, which we represent pictorially, graphically by a rectangle. I might have subsets in that universal set, and those subsets may or may not intersect. For example, in this set, A and B intersect. I have elements that are in A and in B at the same time. We call that the intersection. So A and B, that would be this set of objects right here. If I'm going to talk about the union, A or B, those consist of objects that are in either A or B, and clearly that will include the objects that are in both A, B. So the key thing to remember is A and A intersect B. The key word is and. You have to satisfy both requirements. You have to be in A and in B. And the key word for union is or. You're in either A or in B. Now the or is going to include the stuff that's in both, because you're in either A or B if you're in both. The other notation is you're going to talk about the complement of a set. And the complement we're going to write with a single segment over a capital letter. So this will be, I would read this out loud as the complement of set A. And the complement of set A will be everything not in A. So if I'm looking at everything not in A in my diagram above, it would include everything outside of A. That would be called the complement of A. Finally, we've got a principle that connects both union and intersection, and it's the following. Suppose I wanted to know the number of objects that were in A or B, and I wanted to somehow relate them to number of A, number of B. If I look at the diagram and I say, what's the number that is in A or B? If I count up the number that's in A and count up the number that's in B, I'm going to be counting this middle section twice. Let me do that again. Count what's in A, it's going to include this section. Count what's in B, it's going to include this section. I will have counted that twice. So my number of A or B is going to be the number of A plus the number of B minus, I got to subtract one of those intersection elements that I counted twice. So it would be minus the number of A and B. And your text gives that a fancy name. They call that the inclusion-exclusion principle. I'm just going to say it's a rule that connects union and intersection in a Venn diagram, because that's what it does. We have a rule that connects our union and intersection in a formula. So, page 19 or number 19 on page 570. We're supposed to figure out. We've got a universal set of 85 cars. Parking lot containing 85 cars, and I've got certain features of the cars. I've got 45 cars with automatic transmission, which I'm going to represent as the set AT, and I'm going to put in parentheses there are 45 cars in that set. There are 43 cars with rear-wheel drive, and now I'm indicating in my diagram that automatic transmission, rear-wheel drive overlap. So there's some cars that have both automatic transmission and rear-wheel drive. And then I've also got 46 cars here with four-cylinder. I'll call that the set 4C. And I'm showing that the way I've set up my three circles, I've shown them intersecting such that there are some cars that are going to have all three features. And I've put in parentheses the cars or the number of items that are in the larger set. So RD has 43 in it. But in this set of rear-wheel drive, I've got this area and this area and this area. And these cars, for example, would be cars that have rear-wheel drive and automatic transmission but don't have four cylinders. This region over here would be cars that have both automatic transmission, and four cylinders but don't have rear-wheel drive. So the key here is they tell me that of the cars with four cylinders, 27 have automatic transmissions. So that means in this area right here, which is going to be the intersection of our rear-wheel drive and our automatic transmission, we have 27 cars. We have 26 cars that are in both, what do we got? 26 which are, where's my 26? 26 have rear-wheel drive with automatic transmission. So automatic transmission, rear-wheel drive, I've got 26 in that section. So the question then is, if we also know that there are 21 cars with all three features, can we find out what these missing regions are? And the answer is sure. If this whole set here is 26, and I've got 21 here, I would have 5 left over up here. If I've got 27 in this set here, then if I've got 21 in there, I've got 1 left over here. And finally, if I've got 29 over here in this set, and I've got 8 here, 21 here, then I'll have 8 left over, and I would have 8 there. Then I can go ahead and look and say, well, if I have 43 cars total in this set here, and I've got 34 in these three regions added together, 43 minus 34 would give me 9 in this region. And I can do the same thing over here now. If there are 45 total here, 27, 45 minus 27 is going to give me, what's 45 minus 27? 45 minus 27, 18 in this region. And finally, if I've got 1 and 21 is 27 and 8 is 35, and I've got a total of 46. 46 minus 35 is 11 in this region. And then I can answer the question, how many cars do not have automatic transmission and rear-wheel drive, but do have 4-cylinder? So I need 4-cylinder. But I don't have automatic transmission, and I don't have, so I got to be out of the automatic transmission, I got to be out of the rear-wheel drive, but I do have 4 cylinders. So where's that going to be? That's going to be this region here, which would be 11. What about cars? Part 2, how many cars don't have any of the features? Well, I would add up all of my numbers in here and then subtract those from 85. And that would give me the number of cars that are in the group of 85 cars but that don't have any of the features. And if you do the arithmetic, it turns out to be 12.